verify.
Okay, what's your question?
52.
Number 52. Okay, the diameter of the sculpture near the base is 9 feet. Estimate the corresponding diameter of Babe Ruth's bat. What you need to do there, first of all, number 51, you converted 120 to inches, right?
Mm-hmm.
So you should have had 35 over whatever that conversion was. Do you agree with me? Okay. Now you know that the base of the sculpture is 9 feet, so you need to convert that to inches. What was 120 in inches? 1,440. Okay, now you need to convert 9 feet to inches, which is
108 or 1,080 then?
9 times 12.
112 is 108.
Okay, over or under.
35. Wait, no, because you have to multiply it.
We want to know the actual diameter of his bat. Okay, this is his bat. This is the sculpture. This is the sculpture. This is Babe Ruth's bat. Okay, and then you would just cross multiply and solve. Okay. Jocelyn, do you have a question? That was it? Sweet. What's that? 58. Okay, 58 is just like 57, except when you get to the end, you got to do Pythagorean theorem and solve for a side length instead of a hypotenuse. So, for example, what did we get for RP? 3? RP was 3, right? So, when you were solving for that side length, you might have had 3 squared plus b squared or x squared or something equals 10 squared. Okay, how do you solve this then? 3 squared is 9 plus b squared equals 100. B squared equals 91. So b equals square root of 91. And that's okay to leave as a radical if you can't reduce it. Okay, this would be your final answer there. And then you would have to multiply that by 3 to get your other side. What is 3 times the square root of 91? It's just 3 square roots of 91. Isn't that 3 times the square root of 91? Yeah. That happens. Alright, any other questions? And make sure we get those handed in. Okay, today we are on 8.2. Okay, today's stuff is going to be pretty similar to what we ended with yesterday with proportions. We have a couple additional properties here. Okay, but the properties aren't bad. They are a little more difficult than the properties were yesterday. Okay, so you're going to have to pay closer attention. You're going to have to make sure they're in your notes, and you're going to have to try to memorize these because these properties cannot go on your theorem sheets, okay, but you will need to know them. Okay? So the first property of proportions I have is that if A over B equals C over D, then A over C equals B over D.
Basically, if you flip it, it's still the same.
So basically, instead of going here, I'm going across, right? So I'm just switching it. Instead of putting A over B, I'm putting A over C. And instead of putting B under A, I'm putting B over D. So I'm just lining them up across instead of vertically. Does that make sense, everybody? Just switching them around a little bit. Your proportion is going to be exactly the same. That one's not super hard. The next one's the more difficult one. If A over B equals C over D, then A plus B over B is equal to C plus D over D. These are all in your book, okay, in the green box there. So what are we doing here? What am I doing to get to those solutions? I'm adding the denominator to the top. Is that it?
And divide it by.
Right, but
Oh, yeah.
that's the only thing I'm changing, right? Because B's still there, A's still there. Now I'm just moving this and I'm adding it to the top. Okay, but if I add it to the top on the left side or on the left ratio, what do I have to do over here? I have to move that D to the top over here. Okay, now be careful. This does not say C plus B, so don't take this part and move it over here. It's got to be the denominator that's already with that ratio. So a couple examples here real quick. I just want you guys to tell me whether this is true or not. And that's what your homework problems on these are mostly going to be like. I have P over 6 equals R over 10. They tell me that P over R equals 3 over 5. Thomas, is that true or is that false?
It could be true
It is true.
because it just means that P equals 3 and R equals 5.
It doesn't mean that, but
Wouldn't they don't both
Oh
divide
yeah, they
by
both
2?
have.
they moved it across, right? Instead of lining them up here, they line them up this way. So they actually have P over R equals 6 over 10.
And you just reduce
Is that the same thing as P over R equals 3 over 5? Yeah, that's the same thing. What did I do to get there?
reduce 6 over 10.
I just reduced my ratio is all. Okay, so was this a true statement?
Yes.
Yeah. Okay, let's do another one here. A over 3 equals C over 4. Okay, and they told me that A plus 3 over 3 equals C plus 3 over 3.
You mean that's a 4?
So is this true? No, this isn't true. Why is this not true, Thomas?
Because C plus 3 over 4 is not the denominator. So it would
Right.
be C
So
plus
this
3.
should be C plus what?
4.
This should be C plus 4 over 4. Now is it true? Yes. Now it's true. Alright, does everybody see the difference of the first one and the second one? Alright. Okay, moving on here. We're on page 466 now. We're still working with proportions here, but now we have to set up our own proportions. It gives us a little guidance. Let me get my triangle drawn here. That's not quite the triangle I wanted. Give me 1 second. I gotta make it bigger because when I'm on this video, it's not gonna show up really well. So it's zoomed out a little ways. There we go. Now I think everybody will be able to see it. Okay, and now they're gonna split my triangles. Okay, so I have triangle ABC. DE. And they tell me that AE is 30. They tell me that CE is 10. This is X.
And that one's 16.
And that one is 16. Thank you. Alright, and then they tell me that AB over BD is equal to AC over CE. Now, what I want you guys to be careful with here, make sure when you're setting up your ratios and your proportion, do not plug something different in than AB. Okay, if this says AB, you need to plug in AB. Does that make sense? Because if you plug something different in, it might not work out. Okay, so if you change this, it might not work because the proportion of the ratio might not be true. Does that make sense? They're telling you that this is true for a fact, so make sure you follow these. What is AB? 16. So let's plug it in for AB. So I have 16 over, what's BD? X equals, what's AC?
Zeros.
How do you know it's 20? Because it doesn't tell us that.
7 minus 10.
Right, this is a total of 30, and this little part's 10, so this must be 20. So I have 20 here, and on the bottom with CE I have
10.
10. Okay, and how do I solve this? Cross multiply. Is there something I can reduce here first to make it a little easier on us? What is that, Drew?
The 20.
The 20 and the 10. My zeros are going to cancel, right? Okay, so I have x times 2, which is 2x, equals 1 times 16, which is 16. So I know x equals what?
8.
8. So, if x equals 8, what is the length of BD? 8 what?
Units.
Units. Do labels matter?
Yes, they do.
Yes. Okay, we're talking length, we need labels. What about AD? What is the length of AD? 24, because if this is 8 and this is 16, then this whole thing must be 24. Good. 24 units. Good job. I want to do 2 more examples for sure of this kind of stuff, so make sure you have enough room in your notes. Okay, let's do one with a right triangle. So I have triangle ABCD. This is 2. This is 3. That top right AC is 6. Okay. And let's say they tell me that, how many triangles are here?
2.
There's 2. There's ABC and there is ADE. Good. Okay, these are right triangles. Okay. I know that triangle ABC to triangle ADE is 2 to 5. And that's going to be my ratio there. Okay. I want to know the length of AE. That's my goal. Figure out the length of AE. Okay. So looking at my two different triangles, I already know my ratio is 2 to 5, right? Okay. Can anybody point or explain to me how I got 2 to 5? Because I just made that up in my head by looking at this triangle. How did I get that? Ilya?
Well, the side of AB is 2, and
The side of AB is 2,
and the side of AD is 5.
and the side of AD is 5. Does everybody see that? Okay, so AB was 2, because that was the whole side, and AD was the whole side, which is 2 here and 3 down here, so it was 5. Okay. What do I know if I did the whole side of the small triangle compared to the whole side of the big triangle? What else do I need to do? I need to do the whole side of the small triangle, which is 6, over the whole side of the big triangle, which is,
X plus.
there's a couple ways you could solve this. Okay, do we just want to do x? Because that's what I'm trying to find anyways, right? And I did the small to the big and the small to the big, which I don't know. Okay? So,
2 over 3 plus 6
here, I cross multiply and I get 2x, and I cross multiply and I get 30, so x equals 15. Okay. If the whole side is 15 now, right? You guys agree with that?
Yeah.
AE is 15. Does that mean my triangles are still 2 to 5? If I can I compare 6 and 15 and get 2 to 5? Yeah, because I divide by what? 3, because 6 over 15, divide that by 3 is equal to 2 to 5. Should it be? Yeah, it should be, and it is. Okay. Now, there's another way you could have solved this one, and I'm going to have you do that on this next problem. Okay, but the next problem isn't going to be a triangle. I have A, B. Let's just go A, B, C, D, E, and F. I have 6 units here, 4 units here, and 6 units here. Okay. And they tell me that AE to AD is equal to BF to BC. Now, does it matter if they're giving us this, what we line up? Yes, because if you use something different, you could mess up your proportion and get the wrong answer. So make sure you're only plugging in what they're giving us. Okay? Now, what is AE? Okay? That could be X. Now, I'm going to do it a different way, how some of you might have done it on the last one if you wanted to. And again, there's multiple ways. There's about 4 different ways you could solve this same problem. Okay, but instead of saying that AE is X, let me tell you, I want to know what the length of DE is. Okay, that's my goal. I want to know DE. Okay, so if I want to know DE, where should I put my X?
D.
I'm going to put my X in for DE. So what is the actual length of AE?
6x.
It's x plus 6. And be careful, it's not 6x, because I have to do what with this segment and this segment?
You have to add them together.
What theorem is that?
Segment.
I guess it was postulate. Segment addition postulate. I'm adding two segments to get the larger segment. So I have 6 plus x. You guys agree with that? So I have 6 plus x over, what's AD? 6 equals, what's BF?
10.
BF is 10, because I have 4 here and I have 6 here. So BF is 10 and BC is 4. Before I go any further, should I reduce? Yeah? What's 10 over 4 reduced to?
5 to 2.
Okay, so this is a 5 and this is a 2. So when I cross multiply, 6 times 5 is 30. What is 2 times 6 plus x? Why is it 12 plus 2x and not 12 plus x? Good, you have to distribute. Make sure we are distributing. How do I go about solving this, Adriana?
You do subtract the 12.
Good, subtract 12, I get
18.
18 equals 2x. So x equals
9.
9. So, if x is 9, what is the length of DE? 9 units. What is the length of AE? 9 plus 6, which is 15 units. Good. Just be careful here. It does matter what you're plugging in. So make sure you're only plugging the things in that it's telling you in your two ratios.
See what problem you did.
I solved it differently though.
No.
Okay. Alright, the last thing we have today is what we call geometric mean. So make sure you get this example. We're going to do a couple examples here actually. But get this general form down in your notes. If I remember right from last year, there's about 4 questions of this on your test for this chapter. So you are going to have to know this. I'll show you an example of here of a real life scenario where they would use this. Okay, but in general, I have a over x equals x over b. That's the general form for my geometric mean. Okay. So am I plugging things in for x or a and b?
No.
Which one? A and b. Okay, a and b are not variables that we ever leave in our equations. Okay, so we're plugging in for a and b. So, what if they told me that, let's just say this, they say find the geometric mean of 8 and 12. Find the geometric mean of 8 and 12. Where's 8 going to go?
On the A.
For A. Could I put it in for B?
Yeah.
Yeah, it's not going to matter. Either way, you're going to end up multiplying them, right? Because we're going to cross multiply because it's ratios with an equal sign in the middle. So either way, you're cross multiplying, so it doesn't matter. 8 over what? X equals
X over
x over 12. Right? So I cross multiply here. What is 8 times 12? 96 equals 2x? Why not 2x? Because you add your exponents, right? Okay, so I get x squared. When you multiply your variables, you add your exponents. Okay. Now what, McKenna, what do I do to solve this?
You get square root of 96.
Square root both sides, and I get x equals the square root of 96. Now, can I continue to solve a problem like this? Or is this my final answer?
Should be.
You can keep solving.
I gotta keep solving. What do I have to do to the square root of 96?
Divide it by square.
I have to divide it by a perfect square. What are my perfect squares? 4, 9, 16, 25, 36, 49, 64. Hey, what goes into 96? A 4 does. So when I get the square root of 4 here, what do I get on the other side? The square root of
24.
24. There you go. What's the square root of 4?
2.
2. What do I do with the square root of 24? Divide by 4 again. So I get the square root of 4 and the square root of 6. Good. Square root of 4 is
2.
2. Square root of 6. Can I take any perfect squares out of the square root of 6? No, I cannot. So it just stays as the square root of 6. Good. Gary, what do I do with these two numbers? You remember?
Let's do that.
Do I add them or multiply them?
Don't you just put a square?
No. Well, I guess you could put 2 squared, but that means we're doing what?
What do you mean?
Does that mean we're multiplying or adding?
Multiply.
Multiplying, good. So I get x equals 4 square roots of 6. And actually there it wouldn't have mattered if you added or multiplied, but if you had another 2 it would have, or if you had different numbers it would have. Okay. Just make sure you line your numbers up diagonally from each other so you can cross multiply on geometric mean. Let's do another one. We're on example 3. Okay, let's look at using geometric mean. Okay, it's talking about paper sizes. Okay, with a paper size like printer paper, what's the size of a sheet of printer paper? Close. It's not 8 by 11, but it's 8.5 by 11. Okay, so it's a little bit different. The ratio of the length to the width of a sheet of paper is the same across every country. We just use different units. Okay, you guys agree with that? Other countries use different units than we do. Okay? So it says international standard paper sizes are commonly used all over the world. The various sizes all have the same length, width to length ratios. 2 sizes of paper are shown, called A4 and A3. The distance labeled X is the geometric mean of 210 and 420. Okay? Find the value of X. So what we have here is I have 2 sheets of paper. I have a smaller sheet of paper and I have a larger sheet of paper. And I have 210 millimeters, and I have X, and then I have X and 420 millimeters. So basically in this, my width here, or my length, whatever you want to call it, and this side of the sheet of paper is the same as the bottom of this sheet of paper, correct? Okay. So, looking at this, there's multiple ways to solve this again. Okay, you can either compare or set up a ratio of this side of the small sheet to this side of the large sheet, and then the bottom to the bottom. That's one way. Or you could set up this side to this bottom and this side to this bottom, and you're going to get the same answer. Is there a specific way we want to do this? First way? Okay, that's how last class wanted to do it as well. Alright? That's how I like to do it also. I like to compare my side to my side. So when I set up my proportion, what do I get? I did my side to my side. So I get x over
420.
420 equals, now I need to do my bottom to my bottom.
210 over X.
So it's 210 over X. Good. Make sure if the small sheet of paper is on top, the small sheet of paper is on top. Big is on the bottom, the big is on the bottom. Right? So now from here, this is easy to solve, right? What do I do here? Cross multiply. X times X is X squared. What's 420 times 210 if you have a calculator?
88, 200.
200.
Okay, so I have 88,200. To keep solving this, I do the what? Square root.
My friend is a rat.
So I have X equals 88,200 underneath a radical. Now, if you get numbers like this, you guys might not like me a whole lot, but what do you have to do? You gotta reduce it, right? What perfect square can I take out of that? Drew, do you have one?
No, I was just gonna say,
Okay.
can't you eliminate the zeros?
You can't because it's not like a fraction. We are gonna eliminate the zeros by taking something out though. Gary?
10 squared.
10 squared, which is what? 100. Is 100 a perfect square? Yeah, it is, because it's 10 times 10, right? So if I take out the square root of 100, what am I left with?
8,000.
Just 882, because I just divide by 100, right? Because 100 times 882 is 88,200. What is the square root of 100? 10. Okay, so we knocked off a big chunk there. 882. We gotta find a perfect square that goes into 882.
9.
Okay, so if you take 882 divided by 9,
98.
so I get the square root of 9 here, and I get the square root of 98. What is the square root of 9?
3.
3. What do I gotta do to square root of 98? Gotta try to break it down. Hey, you might have to go through multiple here. Is it divisible by 4?
No.
No. Is it divisible by 9?
No.
No. Is it divisible by 16?
No.
Yes, it is.
No.
No.
Oh wait, no, never mind.
Is it divisible by 25?
No.
No, definitely not 25. Is it divisible by 36?
No.
No.
No. Aaliyah?
It's divisible by 49.
It is divisible by 49 now. Good. So I have the square root of 49 times the square root of 2. Good. Square root of 49 is
7.
7. Square root of 2 is
Square root of 2.
just the square root of 2.
Oh.
Okay. Again, what do I do with these three numbers, Johnny?
Multiply them.
I multiply them. So 7 and 3 is
30.
7 and 3 is
21.
21 times 10.
210.
210. So x equals 210
Roots of 2.
square roots of 2. Good.
Do you have anything to take on homework?
I don't know for sure. I haven't looked that far into it, but it's a definite possibility. Okay? It is a definite possibility. Before, I think you run into something like this on your homework, so let me touch on it real quick. If I get, let's say I get the square root of 19 as an answer. Okay? What is the answer to 3 times that? The answer, if I multiply this by 3, I get 3 square roots of 19. Does that make sense to everybody? Because I'm multiplying 3 times the square root of 19. I think you'll run into that on your homework, so just be careful with that. Okay? Any other questions on this lesson before I give you your assignment? Alright, now I am missing 2 calculators from the ones we already had, so I took the calculators again. So if you know where it is, have it, or have seen it, get that back to me so everybody can use calculators. Okay? I don't know why that won't go up. There. Okay. We need to do, page 468. Nine through 32. Okay. And for 6th and 8th periods watching on the video, if you have questions, you need to come talk to me in the morning.